So here's an example of a cost and benefit analysis for a new proposed ozone standard in the United States. So here's a current baseline standard is 75 parts per billion, right? And so the lower the parts per billion, the higher the standard. Right? And all these comparisons of cost and benefit is always compared relative to the baseline, the current baseline, which is 75 parts per billion. Now, compliance cost, so this will include the industry cost, how much the retrofitting needs to do. And this, comparatively, this is pretty easy to estimate. Right, so now this is all in the billions of dollars. And then the benefit, right, in this policy, or sorry, in this proposal, right, the benefit is measured by annual avoided death by increasing the regulation here. Now, there are other benefits, okay, but for the sake of simplicity, most of the time, these reports will just focus on the main benefits of the policy. Right? Now, so here's a main death. So this is the number 2 in our steps, trying to estimate how many deaths could be avoided due to the increase in the regulation, and then the EPA will have a monetary value that they will use for each life saved. All right, and so you multiply that and you get the monetary value. Now, to calculate annual net benefit, you simply take the total benefit minus the total cost. Okay, you can do that for the other two, and this is where this is primary where we will make our decision. We will say make our choosing which policy to go with. So from this, right, we can see that you choosing the 65 parts per billion standard, right, will give us the highest net benefit. Right? Okay. Benefit cost ratio, right? So benefit cost ratio is taking the total benefit, monetized benefit, divided by the total cost. Now, we don't make our decision using the benefit cost ratio. However, benefit cost ratio, it is still a very valuable measure because it tells us the return on investment. Right? It's basically saying for every dollar that we spend on this new policy, how much value are we getting for that dollar? And so, looking at that, we can see that actually 70 parts per billion. This is a much higher, much more valuable return per dollar. Okay. All right. Now, that is very simple, right? Once we have the estimates and the number. However, in reality, the future is largely uncertain. We don't know what necessarily what exactly is going to happen. Now, for us, we need to make a distinction between risk and uncertainty. So risk, right, strictly, it will be a situation where all the potential outcomes and their probabilities are known or can be accurately estimated. For example, a coin flip is a situation of risk, right? We don't know which side is going to land on, but we do know there are two sides, heads or tail, and we know the probability of landing on each side, right? 50-50. A roll of a dice is also a risky situation. Right, we have the possible outcomes are the number 1 through 6, and the probability of each outcome is 1/6. Right, in risk we can manage. Right, this is why this is how insurance company make money. Right? They manage risk. Uncertainty, right, are situations where some of the outcomes are unknown. Right, and even if we know the outcomes, we can't assign probabilities to them because we don't have a good way of estimating the probabilities. Okay, so uncertainty is going to create much more of an issue when it comes to cost and benefit analysis, when it comes to decision making. But let's talk about risk first. Right. Now, the report that I just showed you, I cleaned up the numbers a little bit because the actual report, actually have a pretty wide range of estimates for the annual avoided death. Right? And you can see here, right, as we increase the standard, right, then the range becomes much wider. Now, if we have such a wide range for avoided death, that means we also have a really wide range for the annual net benefit. Then how do we make a decision? Because now it's not so clear, right, which policies to choose. So in the situation of risk, we're going to borrow something from statistics. Okay. So let's take a look at this example. So let's say we want to construct a dam. Now there are the costs of constructing the dam, construction, operation, environmental damages, and the risk of dam failure. But the potential benefits, flood control, recreation, and hydropower supply. Now, let's suppose that there are four situations or four possible outcomes in the future, right, of the weather, right? And now how profitable a dam is depending on how much rainfall we get. The higher the rainfall, the higher the net benefit. However, it could be the rainfall could be too high where it actually destroys the dam and we get a negative net benefit outcome. Now further suppose that we can estimate the probability of each of these outcome accurately, and we get that these are the probability of the outcome. All right. Now, so to make decisions, right, then first thing we need to do is get the expected value, the expected value of the outcome. Think of this as the expected net benefit. And now this is something we borrow from statistics. But don't worry if you don't remember or never taken statistics. Right? This is a summation notation, like this sigma this big E looking thing. All it is means multiply. Not multiply. You add in a chain or whatever is in here. So what this is saying is you take the x values, so this is x over here in this column, multiply by the probability, and then once you multiply that, then you add them all up. So for example, right, we will multiply across 5 million times 0.27, right? We get 1,350,000. Think of this as a weighted average, and that's really what expected value is. We're simply weighting all the net benefits by the corresponding probability. Once you multiply it across, then we add them all up. And now we can take a risky situation where multiple different outcomes, and we have one number that we can use to make a decision. Okay. Now, what about the projects with the same expected value? Right? What about the project with same expected value? Right? What do we choose? So then the second thing we want to look at is variance. Again, complicated looking formula. You're not responsible to know this. I'm not going to ask you to calculate it. Right? But variance basically is measuring the average distance of each observation from the mean, from the center. Right? So if you have a lot of variation, so I suppose that in low precipitation, you can get a very low number, but in extremely high precipitation, you get a very, low precipitation, low number, high precipitation, very high value, right? If there's a really wide range, then you have a really high variance. One visual way to look at variance is kind of like looking at stocks. Right? So suppose I have two different stocks here, stocks A, and stock B, and they both follow the same trend, right? Meaning that they have the same expected return, the same amount of growth. But one stock, let's say, kind of just bounce around like this, go up and down like that, and they have this trend here. And the other one is much more volatile, so it just jumps up and down like so. Right? Now, if I draw a trend line between the two, right, they will have the same expected value, right? Expected value of A equals the expected value of B. However, the variance of A is going to be much less than the variance of B, right? Because on average, the values, each of the observations in B is much further away from the average, which is this line here. So when you make a decision, the first thing you look at is expected value, right? Now, between A and B, right, you would choose A because there is no reason to take more risk than you have to, right? You're going to get the same expected return on both of these, right? But with A, you get a much less variance, so much less volatility, right? So we can make that decision pretty easily. But then what about A and C, right? You have C has a lower return, okay, but it also has lower risk. Right? So the question is, should you choose C or should you choose A? Now, there is no right answer. Right? It really depends on an individual or an institution's tolerance to risk. Right? So if you are more risk averse, right, then you might consider C as a safer bet. Right? But if you're more risk tolerant, then you might consider A, right, if you're willing to take the chance. Right? So risk aversion is our tendency is observation on human behavior. It's a tendency to prefer certainty instead of risky outcome. So for the great majority of the population, they will not choose risky outcomes unless there is a really significant payout or reward for it. Okay, now that is pretty simple in terms of calculation, right? We can use some statistics and we can still manage risk. But what about when we have uncertainty, right? So when there is uncertainty, then cost and benefit analysis are no longer valid because cost and benefit analysis rely on numerical values, and if we have a situation that's of uncertain, that means we cannot calculate the probability or even know the exact outcomes or the value of the outcomes with any accuracy. Right? So without cost and benefit analysis, right, then we must apply the precautionary principle. Now, the precautionary principle is very broad. Oh yeah, let's read it first. Right, so it is a moral and political principle which states that if an action or policy might cause severe or irreversible harm to the public, the burden of proof falls on those who would advocate taking the action. Right? A way to interpret this is that it's shifting the burden of proof. Say, for example, an oil company would like to do drilling in the community. Right? Now, drilling has never been done in that area before, and we don't know the harm or the benefit of that might come from this drilling. However, we do have a sense of that if drilling begins, then there might be some irreversible damage, right? That might be caused by this drilling. And so when we apply the precautionary principle in that context, and what that means is the burden of proof is shifted completely on the oil company, right? So for the individual or the group that is promoting the policy or the action, they must prove to the public that this is safe. Okay. And the precautionary principle is a way for the public or the people that might be affected to reject the proposal, right? To say that this is not, they're not convinced. We don't think you don't think this is actually safe. Please come back with more information. Right. Now, again, this is a response to cost and benefit analysis, right? Because we don't have numerical values or probability to calculate, right? So when we use this when there is uncertainty and when there is irreversibility. Now, this is widely used in the European Union, but is not commonly used in the United States. Now, this is not necessarily a good thing or a bad thing. It's a different way. It's just simply a different way of decision making, right? Okay. All right. And then there's a lot of interpretation with this because this is a pretty broad definition. There's nothing precise here, right? So it's up to the individual or the institution, right, to decide what is actually what constitute as enough proof, right, that no harm, right, will be done. Okay. All right.